Welcome to the Technology Channel. We will talk today about how AI image generators work from text to masterpiece. An astronaut riding a horse on Mars in the style of Van Gogh. A cyberpunk cat wearing a neon jacket. A serene lake house made of glass and light. Just a few years ago, creating these images would have required immense skill, time, and resources. Today, you just type a sentence. It feels like magic. But behind the curtain, it is a breathtaking feat of mathematics, data, and human ingenuity. This is how AI image generators actually work. Let us talk about the foundation or the brain training. First, you need a brain, and this AI brain learns just like a human artist, by studying millions and millions of existing images. Today, generative artificial intelligence programs have access to a massive database of billions of images and their text captions from the internet. Systems like DALL-E, Midjourney, and Stable Diffusion were trained on colossal datasets. Each image was paired with a text description. This is the AI's art history class, its museum, its entire visual education. But how does it learn from them? This is where the real magic happens through a process called diffusion. Here is the genius part. The AI does not just learn what a cat looks like. It learns by reversing chaos. The training process works in two steps. First, the forward pass, or the messy room. The algorithm takes a perfect image and gradually adds digital noise, like TV static, until the image is completely random. Second, the reverse pass, or the cleanup. The AI then learns to predict how to reverse that process. It trains a neural network to look at a noisy mess and say, that blob of noise looks like it could become a cat's ear, and it slowly removes the noise to reveal the image beneath. It learns the essence of things, not just pixels. Now, let us talk about the generation from your text to an image. Okay, so it is trained. How does it make a new image from your text? Step 1. Understanding your prompt. For example, the text, "A majestic eagle wearing a royal crown," is typed. A language model like GPT encodes this into a numerical representation that the image AI understands. Step 2. Starting from pure noise. Here, the screen shows a frame of pure gray static. The process does not start with a blank canvas. It starts with a canvas of complete randomness. Step 3. The guided denoising, or the magic step. The static begins to swirl. Certain areas start to form vague shapes. The AI now uses its trained brain to denoise this static, but it is guided by your text prompt. At every step it asks, does this noisy mess look more or less like a majestic eagle wearing a royal crown? It subtly pushes the pixels in the right direction. Step 4. Iterative refinement. A fast-motion video of the image goes from blurry shapes to a detailed, high-resolution picture of an eagle with a crown. This process happens over multiple steps, sometimes dozens or hundreds of iterations. With each step, it gets clearer and more aligned with your request. Let us now explore under the hood or the key tech breakthroughs. Two key technologies make this possible and have led to the explosion in quality we see today. First, the clip model, or connecting text to images. Here, a graphic shows a text and images being mapped to the same concept space. Developed by OpenAI, Clip is the translator. It is what understands that the word dog is conceptually closer to a picture of a puppy than to a picture of a car. It aligns language and visuals in a shared mathematical space, allowing the AI to connect your prompt to the right visual concepts. Second, latent space, or working in a compressed dream world. Here, a complex 3D graph or latent space lets similar concepts such as cats, dogs, and cars live near each other. The AI does not work on giant billion-pixel images. That would be too slow. Instead, it works in a compressed mathematical representation called latent space. Think of it as a dream world where the essence of every concept exists as a point on a massive map. For instance, cat is a point near kitten and far away from spaceship. The generation happens in this efficient dream space before being upscaled into a full-resolution image. What about the challenges in the future? This technology is powerful, yet it is not perfect, and it raises important questions. Because it was trained on internet data, it can reflect and amplify human biases around gender, race, and culture. What about the artistic ownership? We mean, who owns the generated art? The prompter, the AI company, the millions of artists whose work was used for training. This is a huge legal and ethical debate. Then we are faced with misinformation. The ability to create photorealistic images of anything poses a serious threat in the era of deepfakes and misinformation. The future is about control. We are already seeing tools that allow for in-painting or editing parts of an image and out-painting or extending an image beyond its borders. The next step is longer, more consistent storytelling, AI-generated video. So, in conclusion, it is not magic. It is a complex dance of statistics, pattern recognition, and guided noise reduction. It is a tool that democratizes creation, but also challenges our very ideas of art and authenticity. What do you think? Is this the future of art, or a threat to human creativity? What is the most amazing or weirdest thing you have generated? Let us talk in the comments. If you enjoyed this dive into the tech behind the magic, hit that like button and subscribe for more content that explains the future. Thanks for watching.